I turned a room divider and some LED strips into this, an LED wall display. When I moved into my new flat, there was this rather ugly grey furniture piece in the middle of my living room. And like every sane person would, I tried to solve this with LEDs. A lot of LEDs. To build such a display, individually addressable LEDs are needed. The color and brightness of each individual LED on this strip can be controlled individually with a microcontroller. To use these strips as a display, we first need to convert our image into a string of colors. The microcontroller then sends this string of colors into the data input pin of the LED strip. The first LED takes the first color it encounters and passes the rest on. The second LED likewise takes the first color of the string and passes the string on. This process is repeated till all the LEDs have gotten their data. To create the big display, I used a total of 100 meters of LED strips. I split it up into 3 segments of each 15 rows, totaling up to a total of 45 rows, with each row having 51 LEDs. This means the display has over 2000 LEDs. Since one LED has 3 colors, red, green and blue, it also has 3 bytes of data. Multiplying this with the total number of LEDs yields that one image is 7,000 bytes big. This concludes that our microcontroller also needs to be able to store these large amounts of data. An Arduino Nano has a SRAM of only 2 kilobytes, so he can't even store a third of one image. This is one of the reasons I chose a ESP32 as a microcontroller for this project. With 520 kilobytes of SRAM, it has plenty of space to buffer these images. It also has Wi-Fi capabilities and ESP Home, which allows this device to be connected to smart home systems. After hooking up the microcontroller with the LED strip, I was confronted with the first issue of this project. It was everything but smooth. To understand why this happens, we have to take a closer look at the LEDs themselves. The chip in these LEDs is a WS2812b. It features an upload speed of around 100 kilobytes per second. Dividing this number by the data size of one frame, we can calculate that the best possible frame rate we can achieve is 14 frames per second, which is anything but smooth. One solution to this issue would be buying a LED strip with a faster chipset. Since I'm already sitting here surrounded by 100 meters of LED strip, it was a little too late for me. So since the upload speed is proportional to the length of the LED strip, the solution I came up with was essentially cutting the strip into 3 sections again, and then having one microcontroller for each of those sections. A 4th microcontroller would then create the images, split them into 3 sections, and distribute them to the 3 other devices. This requires that the communication between the ESPs is fast enough so we don't have a new bottleneck. But thankfully the serial communication between 2 ESPs can run with half a megahertz easily. Another thing to consider is the power consumption of such an LED wall. Cause oh boy, these LEDs are thirsty. Each LED running at full brightness pulls about 50 milliamps of power. Now multiplying that by the total amount of LEDs on the wall, we get that the whole wall could draw a theoretical current of 120 amps, which is crazy. At these currents you need an industrial looking power supply and also very thick wires. You also have to think about power losses through the strip, as the voltage drop scales with the current running through the wires. As I told you before, my LED choice was rather suboptimal, so I would like to recommend 2 other options to you guys. The WS2815 chipset is a 12-volt chipset that has the same upload speed, but at least it fixes the current issue, so you don't have to worry about such a big power supply or thick wires. The second alternative is the chipset called the SK9822, which are sadly still 5 volts, so the current issue remains, but they have a very fast upload speed, since they use a different protocol to upload to the LEDs. This means that the whole LED wall could be controlled with just one ESP easily, and you don't have this issue with splitting it in 3 and all the other complications that came with that. Now if you made it this far, I will thank you for watching. I hope you enjoyed this video of my little project, and I will see you in the next one.